Thank you for coming. Quick introduction. It's our pleasure to welcome Katya Kudashkina for the guest lecture today, an introduction to AI for MBAs. Katya is founder and CEO of Cultura, which is a software company that uses AI to assess organizational culture, to mitigate risk and improve productivity. Sounds pretty mysterious. So she will tell us exactly what this means in a bit. Prior to that, she was involved in another business also as founder, and that company was called Udio. Is that the right way to pronounce it? Close enough. And that company also used AI to optimize water usage in agriculture. And that company was associated with the Creative Destruction Lab and emerged 3 years from that CDL. And before that, I guess you had some other jobs, Canada Pension Plan and IBM. And prior to that, Katya studied engineering in St. Petersburg, Russia. And after that, moved to Canada, where she got first education in computer science, a degree in computer science, and then her MBA from this very school. And in addition to doing what I mentioned she's doing, she's also getting a PhD in deep learning. And if that weren't enough to make us all feel lazy and, she's also a yogi, a surfer, a volleyball player, and a competitive ballroom dancer. All right, so enough said. Thank you very much for coming.
Thank you, Philip. It's always wonderful to be back to this building. Okay, so in 2016, almost 39 billion was invested by companies in AI. Now, somewhere around those years, if you look at the startup scene, you'll see that the financing in AI companies has increased by 10x. Oh, this is where the clicker stopped working, okay. So if these two numbers are really not enough for you to sit through the next 45 minutes of this lecture, so let me tell you a couple of more things. Many of you here came to Rotman School with some kind of ambition. Oh, I hope so. And with that ambition, many of you will end up in some kind of executive positions in different organizations. And by the virtue of that, you will be transforming businesses. Now, in order to transform the business, you need to know what are the tools available to you to do that and how to use those tools. So, if you think about the internet 20 years ago, there was no industry untouched by it. So, in other words, internet changed every industry that existed. So, what I believe, this is what AI is today. So, in other words, 5 years from now, the words that I'll talk in this lecture about will be just so commonly used. So today, you don't have a person coming and telling you what the website is. Okay, so basically, what the whole lecture is going to be about, it will be about what that tool is and what the basic vocabulary is and how to apply it and how to use it so that when you walk out of here, hopefully you feel more comfortable when you are in a conversation and when someone is talking about AI and you can actually understand what it is all about. And you can also go and understand how can you apply it to transformation to the business that you're in, or if you're not, why not? Okay. Philip already touched base a little bit on my background. So on academia side, started with an engineering back in St. Petersburg. Did computer science degree here at Ryerson University, did MBA from this school, which I'm very proud of, and currently working on my PhD in machine learning, in a deep learning focus, and you can often find me at the Vector Institute. Now, on a relevant career side, so I started working at IBM with Cognos Business Intelligence Systems, essentially moved to CPP Investment Board, where I spent 5 years focusing on data analytics. And I founded two companies, Udio and Cultura. And in the middle is my attempt to surf. So at Cultura, what we do is we focus on the organizational culture. The way we do it is we measure organizational culture, so it's not that mysterious as it sounds. And we measure it by deploying a quick set of surveys, so they're very light, easy surveys. And then as a result of the surveys, we combine the data into the dashboard. We provide the analysis of what are the problems in a company from the culture perspective, how to deal with those problems, and we recommend a set of actions. So this is the current company. In a previous company called UDO, so what we did is we optimized the amount of water that needed to produce certain yields. So California produces 70% of world almond productions, and it takes a tremendous amount of water to produce almond. So now, so we operated in California during the drought, so that was very relevant. So what we did is we would predict the yields, and then we would optimize the amount of water. So imagine you get a bunch of fields, then you get a bunch of pumps supplying those fields, and you want to make it really cheap. So you basically want to optimize all of that so that you get the least electricity consumption possible. Okay, so those were the two examples of AI applications, and throughout this lecture, I'll go back to them in a context of the lecture. So why are we talking about AI today? Why all of a sudden it's a big hype, and all of a sudden everyone is talking about it, and it's just really fancy topic. So, and again, as I mentioned, tomorrow or 5 years from now, I believe that this discussion would be irrelevant, that all of this vocabulary will be just our common words vocabulary. So there were 4 things that happened. Number one, there was a huge drop in the computing power and the storage. So essentially now, I don't need to spend tremendous amount of money storing all my data. I can put it in a USB stick and put it in my pocket. And at the same time, they've got GPUs. So basically something that allows me to compute much faster. So if in the past I would have a model that would run for 5 days on the CPU, I plug it into the GPU unit and I have 5 hours to run the model. It's a huge difference, and that difference allows us to basically train the models instead of for months and waiting for the results just in a matter of days. And on top of that, now you don't even have to buy that device. You can simply spin off the server at Amazon and have a virtual server and do it all there. So it's so accessible. Now, even though this is all accessible, you wouldn't be able to do that if there wouldn't be a huge data explosion. So this is where the companies like Facebook and Twitter all of a sudden becoming very relevant, because they produce a lot of data, they publish some public data sets. Or you can go online, you can scrap tons of data from Twitter, and you can do a lot of different analysis. Now, that's not enough. You also got some interesting algorithmic advances. And this is important because the advances like Jeff Hinton breakthrough with ImageNet in 2012, all of a sudden span off all kind of other research. So if you are really curious, and if you start drawing the dependencies from paper to paper, so you'll see that all of a sudden you'll have a paper published, for example, in machine translation with some significant breakthrough, and then all of a sudden from there you'll have a span of different papers in relevant tasks such as summarization. And basically the advances in one field allow to build on top of that and many different other advances in other fields. Now, all of that would also not be possible if we wouldn't have the number 4, which is the emergence of different frameworks, which was primarily open source by companies like Facebook and Google. So we've got PyTorch, we've got Keras, we've got TensorFlow. So what these guys are, and you should be familiar with those names as well, what these guys are is basically a framework that allows us to build algorithms much faster. So you have basically a predefined function that you can simply reuse, and you can build your models very quickly without going too much into nitty-gritty details about them. So those frameworks that actually created things when you see this artificial intelligence and the farmer in Japan applying deep learning to cucumbers. So, and all these 4, so the 3 points here and the frameworks, they all happen together. And if they wouldn't happen all together, then we wouldn't be talking about AI today. And now, it's because all those 4 happen, it's so urgent and relevant that you have so much research happening in this field that it's frankly just really hard to keep up with it. Okay, let's talk about very basic. So the very basic is, this is how we used to do it before. So we got the algorithms and the data, we got the computer, we got a bunch of if-then statements, and then we got some results. In machine learning, and throughout this lecture I'm going to be using the term machine learning and AI quite interchangeably. It's not a bit the same, we'll get to it in a minute. So in machine learning, it's the other way around. So you get the data and you get the results. You put that through a computer and you get an algorithm back. Now when I say you get the algorithm back, what you actually get back is a model, and that model is some kind of function that allows you to predict something, as a simple example. So think about it is, your data and results could be, for example, house pricing. So imagine you have a description of your houses, 2-bedroom, 3-bedroom, big bathroom, a balcony, all kind of descriptions for the houses. And the results here would be the prices of the houses. So you take that, you plug that into your machine, and then you get an algorithm back. So you get a model back that now allows you to model that and predict the prices of the houses as you give it a description of the new house that it has not seen yet. Okay. Basic definition of AI, which is widely acceptable everywhere in the literature today, is that it is an ability of a computer system to perform some kind of function that normally a human would do. Simple enough. So now think about the next few things is this Russian nested dolls. So machine learning is a subset of AI, and basically what machine learning does is it allows systems to acquire their own knowledge by learning from the data. So it extracting some kind of patterns from the data and it learns something. Now, there is a representation learning, which is another subset of it, and the representation learning learns not only about the data, but it also learns about the transformation of the data. And as we go through this lecture, I'll give you an example of what those transformations are. Now, within all of that, there is another Russian nested doll, which is a deep learning. And deep learning is a technique. And again, we'll talk in a little bit more detail about that. The other three definitions that you really should know and be familiar with is supervised learning, unsupervised learning, and reinforcement learning. And so that when you hear people talking about them, you actually feel comfortable and you understand what those are. So the keywords here is in pink. So when you think about supervised learning, you think about the labels. So your data has to be labeled. And the challenge there that it's actually quite expensive to do. Because you either have to have a whole vast majority of data that has to be labeled by human, or you have to figure out some kind of technical way to label your data so that's actually still correct. So now, in the house pricing example, the house prices would be your labels. In unsupervised learning, you don't have labeled data, or you may not even care to have those labels, but what you care about is the pattern. So think about it that you have a bunch of data about your customers, for example, and you want to learn the demographics about them. You may want to figure out what type of customers are coming in the mornings or what type of customers are coming in the evenings. So basically your algorithm learns all of that and kind of put these customers in this sort of buckets. And reinforcement learning is a completely different type of learning. So that's where your algorithm has some kind of agent, and the agent basically sits within a predefined environment, and based on the settings of the environment, it calculates a reward function, and it takes a step forward if it knows that it's going to get a reward, or it doesn't take a step if the reward is not there. So the good example of that is if you think about robotic arm trying to grab something, so if it does grab something, it gets the reward. If it doesn't grab something, it doesn't get the reward. Okay? So three basic definitions, labels, pattern, reward. So now the question is, how is this all different from a classical statistical analysis? So what you see in the example of what you see on the slide, this green line in the middle is something that was generated by regression analysis. And then the isobars is something that was generated by machine learning algorithm. So from that simple example, you could see that clearly machine learning algorithm does something way more complicated than a basic regression analysis. So it basically gives you more information about what you're trying to discover. But now the question is machine learning just a fancy way of doing statistical analysis? And there would be scientists who would throw stones at me for saying that, but for the purpose of this discussion, we say yes. But now, when we say fancier way, there would be a huge magnitude of that fancier, right? So it would really depend how would you define that fancy statistical analysis. Okay, so let's have a little bit of a deeper dive into that. So what we'll do right now, we'll go through a few algorithm examples and their applications, and then we'll go more a little bit of how companies adopting all of that. Okay, so logistic regression, somewhat similar to linear regression. So it's different function, but the output variable, you get the binary output variable, and it's a pretty simple analysis. So a good example of this is you can classify if your customer would buy a product. So there is a company out of Toronto called Dipnify, and this company basically took that and they converted it into demand forecast problem. There's an example of it that you can predict if your tumor is malignant or benign. And there is a company out of Montreal called Imagia who does this. Now, when I'm telling you that these companies solve this particular problem, it does not mean that they apply this particular algorithm. So I'm just giving you a framework of what this algorithm can be applied to. Okay. Linear or quadratic discriminant analysis. So you can think about it as an upgrade to logistic regression. I'm not going to go into the technical details between this and logistic regression. If you're really curious, Google it. There are plenty of information there. What it does is, so basically it's more complicated, and you can predict an employee turnover. So now your output is not a binary variable. Your output now is a probability. Or, for example, you can predict the likelihood of a car accident. Okay, decision trees. Decision trees are something that is really popular in the corporate world. And the reason it's popular because decision trees are highly interpretable. So basically, if you, for example, want to figure out which feature product makes your customer to buy it, you can build a decision tree and you can look at it and you can actually read it. And that's why businesses really love it, because they can understand what it's saying, as opposed to if you give them a neural network and kind of go figure out what's happening inside it. So what decision tree does, it basically splits those features into the branches. And what you see here is a very classical decision tree analysis where I'm trying to figure out if I want to go play sports outside, and depending on the weather, I would go or not. So again, you predict what features make your product to buy the product, or the other good thing about them, they actually are really good at built-in frameworks for calculating those outcomes and probabilities. Now, to build a good decision tree, you actually have to have many branches, so you go really deep into that decision tree in order to get to a good decision. So it turns out that becomes really computationally expensive. So people start building shallow decision trees, but they're not as good as predicting those decisions. So as a result of this, we got random forests. So when you're hearing about random forests, all it is basically a collection of decision trees, put it together, and then we're taking the outcome of each of those more shallow decision trees and we're combining those into some kind of result. And what you see here on the slide, the majority voting is just one of the techniques to do that. So the good application of that is you can predict the call volumes for a company, for example, an airline company, or you can predict the power usage of your electricity grid. Support vector machines. Support vector machines are more interesting and they also quite widely used because, again, they're simple to understand and they're simple to build. Traditionally, they used for linearly separable data. So what I mean by that is that you can clearly separate the data into the two different classes. And if you can't, for example, what you can do is what you see on the slide here is you get some messy data in your input space and you can apply some transformational function. You can project them into different space. That's when they become linearly separable and you can draw this hyperplane between them. So we actually use support, so traditionally they used to use for only linearly separable data. Now you get more complicated support vector machines, so you can do much more fun with them. So in my previous company, Udio, this is exactly what we used to predict the yields. And Another function of this, you can predict how much likely you can buy a product. Neural networks, so let's get to the fun part. So neural networks is actually a generic name for a number of different algorithms. So what you see here, you see perceptrons, you see recurrent neural networks, you see convolutional neural networks, you see autoencoders. Each of them is a neural network. So I'm going to give you just a flavor of what it is. We're not going to go into any mass of this, but this is just to give you an idea of what neural network is and how it's built and what it represents. So if you think about, so neural networks were inspired by how human brain works. It does not work like human brain works, so that is not true, but it's inspired by it. And it's inspired by it in a way that human brain has neurons that get activated by certain function, certain chemical reaction, so they get triggered by something to do something. So when I'm lifting my hand, it's triggered by my brain. And that's triggered by neurons in my brain. So now the neural network would have those neurons, so those circles that you see, so those are the neurons in the neural network. And kind of a simple way to think about it is that you get a bunch of neurons, so and those vertical layers of circles are the layers in the network. So you get a number of layers, and when you train in your data, so what you're trying to do is, so you get your inputs and you get your outputs, and when you put in that through a neural network, and the connections here, so in this case everything is connected, but it could be all kind of different variations within in the neural network. So again, this is just an example. So when you train in your data, what you're looking for is your function, your network is learning some weights that allows you to get from this input to this output. So essentially what happens inside, there is a lot of math that happens inside, a lot of matrix operations, and you learn in those weights that you see in pink how to get from input to the output. So you train your network, and then after that, you take those weights, and you apply that to a different function of what you want to predict. Okay. Deep learning. So, as I mentioned before, deep learning is a technique, and basically it's a technique on learning representations. So what are representations? So what you see here, this is a few layers of the neural network, and you see they just kind of like, as you go a little bit higher up, so in the last layer at the top, you see that there are somewhat like edges of something. So those are representations that the neural network learns. So if we look at it, if we zoom out from those layers, so you'll see is that first you start learning something about the edges, you start seeing some blobs, then essentially you start learning something about the texture, then essentially you start learning something about the object parts, and then at the end of it you're actually able to predict what that object is and which class it belongs to. So essentially, so when we're talking about those representations, what the neural network learns, it learns not only what the object is at the end, but it learns something about the edges, it learns something about the figures. So those will be the representations. Okay, so again, going back to statistical analysis, there is this joke where we say, well, in statistical analysis, we do this and that, this and that, this and that. So this is all the text that you see on the slide. And then in the deep learning, what do? We just stack more layers. So basically, it just, in order to make it more complicated, we just add more layers to the network, and it does something. Okay, so we're going to talk about two primary models of the neural networks in deep learning. Again, those, I'm not going to go into technical details about that. I'm just going to give you kind of the definitions and the applications of what they do and what they are, so that when you hear convolutional neural networks or recurrent neural networks, you actually can be comfortable what people are talking about. So convolutional neural networks, we'll start with those. It's a multi-layered neural network, so you get a bunch of layers, they're connected, and what this network does, it extracts features. And it works really well with unstructured information, such as images. So now, why image is an unstructured information? So when you look at the image, you see whether it's a cat or a dog. So you know what that is. But when I give the image to a computer, what I give it to is I represent each pixel as a number. So essentially I give it a bunch of numbers. So the computer doesn't know what that structure is. It doesn't know if it's a cat or a dog, it just gets a bunch of numbers. So that's why it's unstructured. So there are a number of fantastic applications for convolutional neural networks. So there is a guy in our lab, for example, who is working on medical application, and basically he's looking at different skin lesions and he's trying to predict what the disease is. There is a really cool application in mining by the company called Motion Metrics. So what they do is, so this is a company out of Vancouver, it's a Canadian company. What they do is they predict for mining operations. So let's say if you have this giant machinery and you have a shovel and the shovel has the teeth, they predict when the tooth is about to break. The reason it is important is because in mining, when this is happening, if this tooth breaks, the whole operation stops. And when the whole operation stops, the company is losing millions of dollars. So what this company do is they do the image analysis of those teeth and they predict when they are about to break, so the company can replace them ahead of time so that they don't have any pause in their operations. There is another company called Clarify, which actually a pretty cool company. It helps you to find relevant product by the image. You can Google it for yourself and actually try it for yourself. And of course, there is tons of applications in advertising where basically you start trying to understand what is the reaction to your product by your facial expression. So this is when other companies start knowing too much about us. Okay, now let's talk about, so this was convolutional neural networks. Again, unstructured images, lots of work with all kind of image data. Let's talk about recurrent neural networks and what is the difference. So recurrent neural network is, again, it's a network. It could be very complicated inside, so we're not going to go into that complexity for the purpose of this lecture. The difference is that recurrent neural network also stores information about your data in those nodes, in those neurons. And what it does really well, it allows to learn sequences that produce another sequences. So what I mean by sequence is that if I'm talking about this chair, if I just say a chair, well, it's just a chair. But if I use it in a sentence, that's a sequence. And if you just hear the word chair, it doesn't tell you much. But if you hear it in a sentence, it has some meaning to it. So now image is not a sequence unless you have a sequence of images, of course. And so that's a good example of sequences that if I have my voice recorded, and so that basically becomes a sequence. Okay. The applications which you probably many familiar with are translation. So I'm pretty sure that each of you at least once tried the Google Translator. IBM Watson produces really cool chatbots for customer support. There is a company out of Toronto again called Blue Jay Legal, and this company analyzes cases, and it does it really fast. So as opposed to humans sitting down and trying to figure out what this case is all about, they can do a very quick summary. And another application of summarization is what we use at Cultura. So now imagine, so in the tool that you saw in the Tinder-like looking tool survey, you also have an ability to enter comments. And now imagine if I have 14,000 comments entered by people. Well, I would have to employ a tremendous workforce in order for us to analyze all of that before I can give my results to my customers. So what we do is we use summarization in order to create the summary out of all those comments. And another summarization example, for example, if you have an article and you want to produce a headline, or you just want to produce a very short 50-sentence summary of that article. Okay. Who else is using deep learning? So I hope each of you is familiar with these company names, and if you're not, then you really should be. So those are the companies who do use deep learning a lot, and primarily because they also have lots of data to do that, and you have to have lots of data in order to use deep learning. And they not only use deep learning, so the reason I'm talking about them is they not only use deep learning, but they also produce a lot of fantastic research in this area. And they produce a lot of fantastic papers. Okay. Recent acquisitions. So I want to walk you through a few recent acquisitions. So this is only a tip of the iceberg that you will see here. So there was a company, Blink, that was acquired by Amazon for 90 million. There was a recent acquisition in Canada of Layer 6 AI acquired by TD Bank for 100 million. Whole Foods was acquired by Amazon for 13.7 billion. If you slept through this acquisition, then you really should wake up. DeepMind was one of my favorites that was acquired by Google by $500 million. And this happened actually in 2014 when the company had 75 employees. The reason it's one of my favorites because I believe this was the one that actually kind of rang the bell and it said something like, hey, pay attention, there is something happening in this field. Like all of a sudden Google is paying big bucks for this tiny little company. What's happening? What's going on? So what are they buying? And why did I put Whole Foods in there? Because Whole Foods is not an AI company, as you know. So they're buying Challenge to start with. So they're buying this team of PhD students that has done all this tremendous research, produced these amazing papers, potentially really well working together team. So Challenge is number one. Number two is the data, and that's why the Whole Foods is in there. So they actually buying all tons of data that those companies have, and that's also important. So now think about the Amazon buying Whole Foods. So now Amazon already knows a bunch about you because you probably shop there. And now they bought Whole Foods. Now they know all about you in terms of what you eat and your dietary preferences. So what happens then? So there is actually a pretty cool what-if scenario described in this coming book, which is written by 3 professors here, which I highly recommend. So think about it as kind of an extension of your knowledge. It talks about the economics of AI. And it has a really cool scenario for that Amazon scenario. So, okay, so what we've talked so far about, I hope took away a little bit of this magic about AI. Basically, there is no magic behind it. It's not like you get this magical algorithm that just creates its own algorithm and all of a sudden everything works. There's a lot of math behind it and primarily a bunch of PhD students. So, why AI is not in every business yet? Why, if it's not as magical, why, if it's really simple, why not every business is adopting it and applying it already? So I believe there are 3 reasons for this. So number one is converting a problem from a business problem into AI. And this is where a lot of you would come in, and if you understand a little bit about AI and how it works, this is where you're actually able to convert that problem. A lot of AI problems is a prediction problem. So what I mean by that is, if you're thinking about the self-driving cars, well, you're not just trying to make a self-driving cars. Essentially what you're trying to do is you're trying to predict of what a human would do in that situation. Would a human steer the wheel to the left, or would a human steer the wheel to the right? So a lot of this is simply a prediction problem. And you also want to make sure that you're addressing the right type of problem. And I'll go back to that point. The second part here is actually a little bit more on this first part. You also get a lot of disconnect between the fact that the business don't understand a lot about AI, so they don't know how to convert the problem to start with, and then they don't know how to move forward with it. And then the other part of it, that if you just get an AI person, well, the chances are that they are going to understand your business problem are actually very low. So you get this big disconnect that AI people don't understand what the business is about, the business people don't understand that what AI is about. Okay, then the second part is this trades-off, and the trades-off basically is, do I keep this associate who is doing this job and keep paying this associate 80 grand per year, or do I build it in-house, or do I buy it? And the trade-off is such that, let's say if you decide to build it in-house, what happens is that every of your AI problem, in a sense, it's a little bit of a research problem. What this means is you actually don't know what you're going to get at the end. So, for example, you can spend 80 grand, you can run it for 2-3 months, and you get a really crappy model at the end, and you wouldn't know what, let's say you want your model to predict 90%, with the accuracy of 90%, but you get barely 50% accuracy. So, and then you're saying, well, I just wasted 80 grand in 2 months on this project. So why would I do that? I'll just keep this associate who I'm paying 80 grand per year, and I'll just keep that person running. And I believe that's a wrong decision, because essentially, like, you need to understand how to convert your business in order to apply AI, because it's coming. Otherwise, your business is going to start lagging behind, like a number of them already is. So, of course, you can buy. So the other solution here is you can buy out of the box AI tool, and this is what's happening today. So we get this number of these AI companies, and each of them is very specialized. So each of them is kind of like this tool that you can apply to a very specific, narrow problem. So you can end up essentially buying a bunch of those tools. And of course, the other problem here is the data and the data scientists. So this is why we're talking about you need tremendous amount of data in order to produce, for example, deep learning models. So you have, for example, people coming to me and saying, hey, I've got this 5,000 data points, can we do some deep learning? Well, the answer is no. You need way more data in order to produce deep learning models. And of course, the last part of it is that you have to have data scientists, and you have to have data scientists who are actually understanding your problem and doing something right about it. And this is becoming a scarce resource today. So the four things here to look for is understanding the problem, understanding how you take that problem and how you convert that into the AI problem. And let me give you an example from the couple of businesses that I've built so far. So, for example, this is also correlated to building the right hypothesis. So, for example, when in my previous company, Udio, we didn't just go and predict how much water they need. So the problem was that the price of water is insanely high. But we didn't just go and start predicting something about the water. So instead, we actually predicted the yields, and then we used that as an input to an optimization problem, where we would optimize these pumps, and essentially they would save on electricity, and as a result, they save a lot of money on using water. So that's kind of, for you, an example of how to think about converting a problem into some kind of prediction problem. It might not be the exact thing that you want to predict, so there might be different ways of looking at it. So similarly, at Cultura, we don't just go and predict the corporate culture or anything, like we don't do any prediction about this corporate culture. Instead, what we're doing is we're utilizing AI essentially to power up our backend, so that I can have a very small number of people running the company as opposed to employing an army of those. Okay? The other point here to watch out for is the evaluation of the model. So there are two things about that. Number one is you need to know the right metrics in order to evaluate the model. So this is where you need to have an actually really good data scientist or machine learning person who understands that metrics. So, for example, your accuracy may not be the right measure for it at all. So that's number one. Number two there is you also need to think what is the accuracy you need to have. So this is where you, as a business person, need to make some decisions. So going back again to our yield prediction example in my previous company. So essentially the choice that you need to make there is 99% accuracy good enough or 70% good enough? So in the yield example, our accuracy was actually with an error of plus minus 15%. But guess what? That was good enough still. Even we were plus minus 15% correct, but that was still good enough to save tremendous amount of money. So, however, if you're thinking about prediction of a diagnosis for a medical patient, and even if your algorithm is 98% correct, and you go and say this medical patient's their own diagnosis, well, they might have a heart attack instead. So you really need to think about what are the right ways of evaluating and what is the threshold that is acceptable for your business. And lastly, of course, the amount of data. So this is where a lot of troubles come in, because some companies, they just can't build the AI models because they simply don't have enough data. And that's where they start using a lot of outsourced data, publicly available data set, but even those sometimes are not enough to build what they want to build, because the other problem that becomes important here is that you may use some data to build a model, but that model may not be transferable to a different domain. So for example, if I have a TD bank doing the model for them, it does not mean that they could use that model and give it to Scotiabank and apply it, and the model would predict the right thing. So there is a whole domain transferability problem in AI. There are a lot of people working in this area, but it is still a problem, so that's why it is important where the data is coming from and what that data is about. Okay, so this was a very basic introduction of AI. So we can go to questions, and I would say if you have some very, very technical questions, we can leave them at the end. They can stick around. So you might want to ask something that is more interested for the whole audience. Please. You know, there is I saw the mic here somewhere. And okay. You might just have to be real.
Okay. So with open libraries such as TensorFlow and Keras, would you think the AI industry has a relatively low barrier to entry? And if yes, how does an incumbent company like yours to keep their competitive advantages?
So let's go through the first part. It is a lower barrier to entry. So that's why, remember if you saw in the presentation, I was showing you this example of this farmer, a Japanese farmer using deep learning to basically what he used deep learning for is to differentiate the type of cucumbers they have. And that was very applicable to his business. So what he did is he simply used TensorFlow. So it was very easy for him to take the TensorFlow without tremendous amount of knowledge and use it. So it is easier to entry. Now, if you, again, you can build a model, but if you don't have enough of knowledge what's in there and how you actually should evaluate your model and what are the right things to measure, then the model just might be useless. So again, you can build a model quite easily. In fact, you can literally build a simple model, in less than a day, and it doesn't take much now. But is it the right model? Is it measuring the right things? So those questions would come up, and it might be, right? So now, how is it different for the competitive advantage? So there are a few things. So from my perspective is, I believe that if I just see a company, like let's say if you're talking about a startup company, if I just see a company that just doing some basic algorithm and didn't produce anything other than that, so if it's a company that just utilizes TensorFlow or Keras frameworks, whatever, this company doesn't have much behind it, right? So this company is not really valuable and interesting to me. Like let's say if I'm interested in investing in this company, for example. But if this company actually produced some interesting research on top of that, if this company has the scientist who has also written some papers, so that's when it becomes more interesting. So you really have to kind of dig deeper into what the company is and what IP they have. And the other part of it is that it's the data. So for example, a lot of investors, when they consider the investment in a company, they not only look at what you already have, but they look what is the data that you already collected. So that, and then there are a bunch of other things that becomes a competitive advantage, of course. You're welcome. Please.
So a lot of people seem to think that AI and machine learning, these algorithms, they're unbiased, they're fair. But there's a lot of growing concern that I've read about that they're basically encoding or hard coding some of these implicit biases. So how do you audit that? How do you make sure that as a business person using this tool, that it's giving you correct results, true results, and not that it's not biased? How do you audit that black box?
You can't really. So the best advice that I would give you right now is that you have to sit down with whoever is writing that algorithm, and you have to understand what the parameters that they put in to start with. Because when you're creating an algorithm, so I'm putting some parameters. In fact, even when I'm designing, if you saw that neural net, again, even when I'm designing my neural network, I'm already biased. I'm already biased by definition from the way how I designed it. So there are tons and tons of biases that go in. Forget about even the biases that comes from the data. So this is just from the creation of the network to start with. And the best thing that you could do is really, so first of all, to understand what are they, just be aware of them. Like, you can't avoid them. Right now there is no real other way. Understand what they are. So really sit down with if you have a data scientist or machine learning person who's doing it, sit down and understand exactly what they are. And then test it. You have to test it on the different domains to make sure that it's as much unbiased as it can be, but the biases are going to be there today regardless. So that's not a very optimistic answer for you, but it is what it is.
Thank you for your lecture. It's my understanding that today AI is a big differentiating thing for companies, those who employ it. In the longer term, with companies, all companies employ it and hiring data scientists, what do you think is going to be the critical factor that will separate successful companies from the other ones? Thank you.
I think one of the things that you need to understand as a critical factor is how you can start converting your business to AI business. Not necessarily to AI business, but how you can start applying AI to your business. And that requires not just understanding the problem, but it requires actually way more than that. So you need to understand the problem. You need to understand what are the algorithms that are available to you to solve that problem. You need to change your workflow. You need to change your business workflow in order to adopt that new way of doing things. Because essentially you may have no longer people that were doing that, for example, or it might be kind of an add-on function. So to be very clear, AI today does not exercise a judgment. It only kind of a prediction function. So it can predict, but it cannot judge that prediction. So you may have pieces that would be predicted, but you still may have to have a human who will be making a judgment based on those predictions. So now, in order to do all of that, and put those pieces together, you may have to change your workflow. In order to change your workflow, you have to change the culture. You have to change how people think about it. So it's actually one of the things that we started doing now at Cultura is we actually look in how businesses are adopting AI, and is their culture ready for adopting an AI business. Because essentially you have to change so many things. And think about when people, back in the days when people brought computers, and there would be companies who would buy 20 computers, they put them in a box, and then they say, well, hey, I bought these 20 computers, but I'm now, going this digital whatever, but I don't really know how to use them. Right? So you don't want to be that company. So all those companies who bought those computers, they had to think how to change their whole business operation in order to use those computers. So they may have to completely redesign their org structure to do that. So you have to remember that this workflow and the people, they also have to adapt in order for a company to apply AI.
Hi. I'm not sure if this is a somewhat technical question, but I want to ask what are the main differences and advantages of deep learning versus traditional machine learning?
So deep learning uses, basically the main thing about deep learning is that it does a lot about so your networks, so first of all, your networks are way deeper. So you get this really, really gigantic neural nets, which would have like hundreds of layers in them. And the layers, the main difference is that the layers, so in a normal network, you just learn about very simple things. That you learn something about the data, you build this function that predicts you something. Here, you're not only learning about the data, but you're learning something about the representations of the data. So if you remember in the lecture, so I was showing you these different pictures where you're kind of evolving from learning the age of, like I'm learning what the age of this, I'm learning what the age of this chair. Then essentially I'm learning something about the textures. So you're learning kind of features of your data. Okay, so that's the difference. And of course your networks are just very, very deep.
Thank you. So two questions, if I can. One, can you give us an example from your company, Cultura, of a project so we can kind of like see the picture, what it would look like, and if there are any limitations to your recommendations? And secondly, I was just wondering with the trend in Europe where you see some of the banks being forced to share data with retailers, etc. Do you see this as a trend potentially in the future where data could be more accessible to companies that don't have as much resource and changing the industry in that sense?
Let's start with the second one. I hope it is a trend. I hope it is a trend, and I hope data will become more accessible. And there are lots of tricks about the data, who owns the data, and there are of course a lot of concerns also in Europe about the privacy of the data. And it's hard to tell whether it's going to be a trend right now or not. If it would be, it would really make a lot of businesses, especially a lot of AI businesses, it would make our job easier, right? So we would just have tons of access to the data. So I'll go back to my previous example of my previous company with agriculture, where so there was this open ag association, which basically they combine a bunch of different companies, and the point of that was they say, let's share all this data, let's have this just one hub where you can come in, you can build your API, and you can share all this data, and every other company in it would benefit. So everyone joined in, and everyone said, yay, that's great, that's a great idea, let's do it. And then what you start finding is that companies that joined, they didn't want to share their data, but they wanted to use someone else's data, right? So, and of course they didn't want to share that data because it took them tons of time and effort to find it and to build those data sets, and that's also their competitive advantage. So it's kind of challenging, so I don't know if it would be a trend, but I really hope so. Now, so that project, by the way, died completely, so no companies really wanted to, so it kind of sits there and doing nothing really. So as an example, so that it might end up in silo. Now to your other question about Cultura, what did you mean by the example of the projects?
Sorry.
Just kind of understand, to help us to paint the picture of how a project would be executed. Like, do you ask questions, like from the video we could see, and what are the limitations of the suggestions you give to the company?
There are no really limitations right now. So the way it works is we start with a meeting with an executive team, and we identify what is the strategy that the company is employing. And if they're doing any strategic change management, so that is the primary part when we become really interested. And so depending on that, we define what are the things that we will measure for them. So because the way it operates is we go in a cycle of 12 weeks, and for every cycle we define what we want to measure. So, and the reason for that is because the way our surveys are built, they're very light ways. You saw you just go quickly, swipe left and right. And so what that allows to do is that allows employees to use that in less than 2 minutes. So 2 minutes per week and you're done. But what that allows us to do is it allows us to build time series data so that we can learn something about the culture of the company. So every week we'll learn something about the culture of the company. So, and depending on what the company is about and what they're doing in their strategy, so we kind of design it for them so that they can pick what they measure for during those 12 weeks. So, and then we do the analysis of that. So then we go to the next cycle, the next 12 weeks, where we can change the things that we measure, and then we do the analysis of that. And frankly, it depends on the company, so then we produce a bunch of results and graphs for them, and where you could see, especially like one of the specialties that we do is we use the point when they implement something, and it could be something related to change management. For example, and it could be very, very small as you just did some training for your employees, or it could be as large as you changing your whole compensation structure. And then we measure your culture relative to that. Like, how does that affect your culture? So if you're really interested, I can show you some examples after.
Just to quickly follow up on this, what would be some interesting things that measure culture? Like, what are some things that you measure that is a descriptor of culture?
Sure, that's a great question. So what we measure is, so we actually work with another professor here, whose name is Dr. Anders Tilsik. So he has a book coming up, so what went in the foundation of this book is a lot of what we basically translated into our software. So as an example of this would be, think about the concept of speaking up. So a lot of, what speaking up means is how comfortable your employee is to come and speak forward, whether it's going to be about the problems or whether it's about new solutions. So this translates a lot to innovation. If your company, so speaking up breaks into a lot of kind of sub concepts that we measure, and they're very specific. But as an overall umbrella, what this translates to, if your company does not have a good culture of employees being comfortable to come to your boss and speak up, whether it's about, just a problem that they have, or let's say if they don't have an incomplete solution and they're just shy to come and talk about it, so that actually becomes a showstopper in the innovation for the companies. So what happens is that employees don't feel comfortable to talk, not only the problems, but about completely brand new solutions. And the companies don't innovate well if that is not the case. So this is just one of the things that we measure.
Just wondering about, you talked a lot about the inherent biases that exist within the creation of the neural network. And so as far as I understand it, if you have a large amount of data but you don't have a feedback loop, you're effectively just doing data analytics. So it seems like to me a big area for advancement within the usage of AI and deep learning is how effective you could make that feedback loop, and is there ability to ultimately input some type of neural network into that so that you can better analyze any of the data that you're getting back from your analysis in order to better predict your results. Can you elaborate on that perhaps?
Are you talking about the feedback loop from, so let's say you already build a neural, just make sure I understand your question. Let's say you build already a neural network, you deployed it, and then you're getting the feedback loop from the customers, for example.
Exactly, yeah.
Yes, and the companies are doing that. So, it is happening, but even with that, it's still not enough. You still have biases. Because even your feedback loop, in fact, is often biased too. So the way the feedback loop happens is you constantly update your algorithms, actually, or you utilize in what's called online learning, which is basically you learning just on the fly from one single example every time. So it is happening, and it would be a really bad AI company if it would just train its algorithm once and did not utilize any ongoing feedback at all. That would be a really bad AI company. But with that, you still have biases happening, and there is no great solution to it right now because humans are biased by nature.
Not to get carried away with buzzwords, but with the AI and machine learning conversation, how do you find, with the introduction of quantum computing and how that's going to change the game, so to speak?
Okay, I'm not a quantum computer expert, so I wouldn't comment on that because I don't find myself having enough knowledge about quantum computers. So there is a lot of happening. Creative Destruction Lab has a whole stream now of quantum machine learning. There is still a lot of debate what's really quantum computer and what's not. So there are companies that are doing some real quantum machine learning, presumably. There are companies that just saying that they're doing quantum machine learning, and what they really do, they're just doing machine learning without any quantum, so you can just take real normal algorithms and do exactly the same. So other than that, I don't have more background on quantum to comment on this.
Other questions? Maybe one question. What would be some words of advice or comment you can give to MBAs who are interested in further pursuing that? Maybe if you can comment on, going after graduation or for internships between the startup culture. So I understand that on the research front, Toronto is doing very well, right? There's a lot of innovation and history here in terms of AI, and there's a lot of startups. Between the startups and the more established companies that are getting into AI, what are some observations as somebody who's been in this area for a while?
I would say don't get comfortable with things. Even if you think you learn something a little bit about AI, don't get comfortable with that. The field is evolving so fast and so rapidly. Keep an eye on it. If you really want to be kind of attached to this field and you want to transform your businesses, to be able to use this tool, make a friend in data science and make a data scientist friend. Bug them to sit down, find a person who is willing to sit down with you and just explain things. Make sure you understand at least one single example about it. And so, for example, I'll give you an example from my experience. So when we were originally doing prediction with UDO, so that was like, so we utilized AI. I thought I understood a lot about it. Well, it turned out when I started doing my PhD, so the reason I started working on my PhD was because I said, well, you know what, I thought I understood, but I don't think I actually do. I think I need to learn and understand much more about it. And now as I do, not that I encourage you all to go do PhD in AI, but now as I actually learn more about it, it becomes such an amazing eye-opener, and I understand so much better how to apply it to the business. I understand so much better what we did before, in fact, and it's a game changer when you understand things. So make sure you understand. Don't get comfortable with the definitions. They're going to change. They're going to evolve. Make sure you keep an eye on that and understand all of that. That's my best advice.
All right. Thank you very much. I think we're at time, right? 3:30. Thank you very much, Katya, for coming.